Saxon Advanced Mathematics. Ta-da! It's lesson 28 in a brand new book. Are you excited? I love starting new notebooks, you guys. It brings out the total nerd in me. But here we are. I'm excited. Fresh new notebook, lesson 28. And it's got two topics. The first one is easy, which is good because the second one's gonna blow our minds. But the first one's a piece of cake. So, this topic relates to problems in usually statistics and probability, not a lot of algebra, not a lot of pre-calc, but quite often in, like I said, probability and statistics, there are times when we have to multiply a number by every number less than it, every integer down to 0, right? So it's a situation where, let me just show you another one. You can see exactly what I mean. I don't have to try and put words around it if I show you, okay? So that's the kind of calculation. You start with a number and then you multiply it by everything little beneath it that goes underneath it in order. We need a name for these. We need a symbol for these. We call them factorials, which is a fancy way of saying multiply a number by every factor, every integer factor, all the way down to 1. The way that we write them, this one is 4. Factorial is how we say it. It's literally an exclamation point. It's such a fun symbol. I don't know who came up with this one, but I think it's really fun. All right, and we can calculate them by hand. There's a button on most calculators, and I meant to check before I started taping this. I'm pretty sure it's on the phone calculator, like I use. We can do easy ones by hand. 28.1. It says evaluate 5 factorial. All right, well, we know that that's equal to 5 times 4 times 3 times 2 times 1. Here's the thing, times 1 we can always just ignore because that doesn't mean anything. And then we can look for patterns. Here we have a 10, and here we have a 12, so we can say that this is equal to 120. That wasn't too hideous, right? Yay. But you can see, anything this big, no thanks, I don't want to do that, right? What's fun, and we're going to use these in problems a little bit later. We're not going to do a whole lot with factorials, but we will use them to some extent. I think it's more fun when they're like this. 9 factorial divided by 3 factorial times 5 factorial. I'm going to write it all out, and then you'll be able to see the patterns, right? Okay, so the top row is going to be 9 times 8, right? I'm going to write the whole crazy thing out. All the way down to 2. I do not need to write times 1, even though theoretically it's there. Over, okay, we'll do 3 times 2, times 5 times 4 times 3 times 2. Okay, here's the way I handle simplifying this. I take the biggest number and the next biggest number, and I see if I can cancel them against each other. That way I can get rid of the most factors in a clean sweep, right? So I'd like to cancel the 2 biggest numbers against each other. So I see, okay, that's gonna work, right? I can, let me get a piece of paper so I can cover some of this up. If I ignore the bigger digits, I see that 5, 4, 3, 2, 5, 4, 3, 2. I can cancel all those out. I could cancel the 3 2s, but I'd rather get as much in a single shot as I can. So look, all of that and all of that. Yay! Now I look for what else I can cancel, and I say, look at this. 3 times 2 is 6, so I can cancel those. That leaves me with just 3 numbers to multiply. 9 times 8 is 72, so I'll do it here. 72 times 7, 14, 49 plus 1, 500. Oh, 49 plus 1 is 50. That's the right answer. Okay, the canceling part is fun. The multiplying gets really tedious really fast, but we can do it. So now we can take what we learned here about how to simplify these bigger numbers without, and I'm going to show you how to do it without writing everything down, because I mean, life's too short, you guys. We don't need to do that. Here's the problem. 14 factorial over 6 factorial times 11 factorial. Okay. We're going to write this as 14 times 13 times 12 times, and instead of writing all those other ones out, we're just going to write 11 factorial. On the bottom, I'm going to go ahead and write out the 6's. 6 times 5 times 4 times 3 times 2, but I'm going to leave this as 11 factorial. Now I can cancel those, and I don't have to write everything out. This is a simpler way to do it. Okay? So now I'm just looking for, excuse me, other things to cancel. 4 times 3 is 12, so I can cancel that against that. I could do the 2 and the 14 and do a 7 up there. And that looks like about all I can get. So now my problem is reduced to 7 times 13 over 6 times 5. This is 91, I can do in my head because it's 70 plus 21, 91, and then the bottom one's pretty easy. And that's as far as we can take it. Final answer. So there's factorials. Nice little shortcut, simple concept, fun symbol, what's not to love, right? Okay, now that we got some love from John, we have to face a relatively grisly type of problem. These are called abstract rate problems. It's part B. We were fooling around with these the other day. We were talking about, we took our basic idea, which is distance equals rate times time. And we were playing around with that a little bit. We were saying that rate times time can equal a job. And we can also factor in multiple people doing the same thing. And we can say rate times time times workers equals a job. Remember all this? Yeah, we had the babies and the bottles and the gallons of milk. I love that problem, but it's a little bit of a headache. We're not dealing with this today. This is off in its own separate bubble. And we're not really dealing with that. We're going to stick with this equation. Here's one twist. We can take this equation and we can solve it any way we want, right? So we can say, if I divide both sides by t, for example, I can say that rate equals time. No, rate. Yeah. We're just going to do simple algebra. So to solve for time, here's our original equation, right? We would divide both sides by r. So we can say that time equals distance divided by rate. And if we want to solve for rate, starting with our original thing, we divide both sides by t, and we can say that rate equals distance over time. So between these three, this was just simple algebra, right? I was just sliding things around to isolate different letters. These are going to be helpful to us in today's drama. Because what we can do is we can solve for any one of the variables that we like, which is helpful. What is not helpful is that, let me just say the other thing that is helpful. Remember how I started playing around and saying, let's keep our units in the calculations, and when we cancel those out, we can make sure that we're doing the problem properly? We're going to keep doing that in this work today, which is going to be super helpful because here's the thing. We're not using numbers, we're using letters. They're all going to be abstract values. Which means it's going to look really nutty. But that's okay. We can do it. We only have 2 of these problems. Let's start. I'm going to be an optimist and assume we can get it done in this space. We're up to number 5 already. Oh, I skipped a factorial problem. Oh, let me just show it to you. It says use the factorial key on a calculator to help evaluate all of that. Okay? And this is what John points out, is that it could be rewritten, right? We only have those. No, I'm not going to talk about this now. It's harder than I thought, and I don't want to distract us from this. Let's go back to this. I'll talk about that later. Okay, so abstract rate problems. Here's what we've got. The train traveled m miles at p miles per hour and still arrived 1 hour late. How fast should the train have traveled to have arrived on time? So, this is our distance. This is our rate. We can tell by the units what they are. And this is what we know about the time. We arrived 1 hour late. Okay. So, what we need to do is we need to figure out what our time was. We know we were 1 hour late, but we need to describe it with these letters. Time is equal to distance over rate. So, time is equal to distance over rate, and in this case, that would be m miles over p miles per hour, which we can write as a fraction as well as like this, right? It can be like this, miles per hour. Okay, so this looks good. This is our new rate, but what in the heck is this? Well, just like with complex fractions, we want to multiply by the reciprocal to make this go away because we don't want to have all of these units. So I'm going to do it by hour over miles. We have to do it to the same, to the top, right? Just like complex fractions. The miles are going to cancel. We're left with hours on the top. This all goes to 1. So our time is m over p hours. We have no idea what that means, but we figured out the time based on that. So I'm going to write it over here, m over p hours. Okay, now John tells us that we need to refigure the trip to figure out what the rate should have been if they would have arrived on time. So now we're going to do the new distance, rate, and time. The distance is going to be the same. It's going to be m. And the time has to be 1 hour less, right? So the new time is going to have to be m over p minus 1. Right? We were 1 hour late, so we have to subtract 1 from our old time. And then we use this information to solve for r. This was the first scenario. This is the second scenario. All right? And so once we get these, we can put them in a fraction and simplify it. All right. So the first thing I want to do is make this into a single fraction because this is 2 separate pieces. So we need matching denominators. I'm going to multiply this by p over p. And our new time will be m minus p over p hours. And our distance is m miles. I can write that in. Okay? And then here in this box, I'm going to solve for r. R equals distance over time. So it's going to be distance over time equals, the distance is m, the time is m minus p over p, this is miles, this is hours. Do I want to write that in there? I kind of don't, but I kind of do. I'll write it in. Okay, and now we put on our complex fraction brains and go, okay, we want to turn the bottom to 1, so we're going to multiply it by p over m minus p hours, just the 1 unit. We have to multiply the top by p over m minus p hours. It's really hard to see. Let me just move my whole book up. Okay, so I'm complex fractioning this. This all goes away. And up here, I get that our new rate equals m times p over m minus p miles per hour. Is that the right answer? Moment of truth. Yes. This hours unit isn't affiliated with the top or the bottom. It relates to the whole thing. So when we multiply by the reciprocal, that doesn't really have to go, it's kind of on the top, I would say. Yes, and so here it's on the bottom. So that's how we get miles on top, hours on the bottom. The units is a little weird. If you don't fully understand that, it's okay. If you understand how we manipulated the other pieces, you are doing really well. All right? So we have one more of these to try, and then I'm going to go back and show you that factorial problem, because there are probably some in the homework. Okay, example 28.6, and I'm just going to write my 3 equations up here. Distance equals rate times time. Time equals distance divided by rate, and rate equals distance divided by time. It's easy enough to find these two algebraically. It's also easy enough to remember that distance is like the product, and then you can divide by either factor. I don't know. However that goes in your brain. All right. The boat traveled k miles in t hours and was 40 miles short of the goal when the gun went off. If the skipper tried again, how long would it take him to reach the goal if she, the skipper is a woman, if she increased the rate of travel by 10? Okay, so here's scenario 1. This is the distance, right? Because it's miles. This is the time, right? And we don't know the rate. So let's figure out the rate. The rate is equal to the distance over the time. It would be k miles over t hours. I can never decide if I want to make these 1 fraction or 2 fractions. I go back and forth. All right, so now we've got everything for the first part of the journey. Now in the next trip, we need to increase the distance, right? Because she needs to go the full length, and she was 40 miles short last time. So the distance is going to have to go up, right? So that's the new distance. And the rate is going to go up too, right? It says that we're going to increase the rate by 10 miles an hour. So we're going to increase the rate by adding 10. And what we're supposed to find out is what would the new time be? How long would it take, okay? So what we want to do is take these new values and solve for t. okay? So what we have to do is take our old values, plug them into this. The distance was k, so this would be k plus 10. The rate was k over t. Oh, I made it backwards. K over t, and we have to add 10 to that as, oh no, this was 40, sorry. Right? K over t plus 10. This is miles. This is miles per hour. We need to clean this up so that they match. So we'll multiply this by t over t. And look, there's my shorthand way of showing the final answer, right? I multiplied this one by t over t. Now the denominators match, so I can do that. And I don't have to rewrite it. Yay. Time for a sip of LaCroix. All right, now we're ready to take these values, solve for t. T is equal to distance divided by the rate. The distance is k, oh, I'm having a hard time writing what my brain is telling me. Miles over k plus 10t over t miles per hour. All right. That's pretty good. We're back to complex fraction land. So we want to take the bottom, flip it, multiply bottom and top. So the flip will be 10 over k plus 10t hours miles. Now all that cancels, but before I draw a line through it, I want to do the top. T hours over k plus 10t miles, right? Bring the units up. Everything's the reciprocal of this. This all goes away now. Now we need to squish this. Let's see what happened with the units. So the miles cancel. So my final answer, this needs a binomial. This, or a parentheses, because it is a binomial. So now I have in my numerator, I have this little t. I'm going to do that first. Then I'm going to do this. I could have written them in the other order, but I don't want to. The unit on that is hours, but I also have a denominator. It is k plus 10t. And my unit got canceled, so all of this is just a reflection of the hour. Let me double check. Yay, we got it right. Oh, you guys, these problems are really hard. And our unit ended up just the way we want it. Okay, here's what I have to say to you. If you need to rely on the solutions manual to walk yourself through the first few rounds of this, there is zero shame in that game. My recommendation is start by figuring out your distance, rate, and time in the beginning. That's usually straightforward. Make sure you have these formulas written on your page so you don't have to stop and think about them as you're trying to get your work done. That's a really weird puffy cloud, isn't it? So have those handy. John usually gives you 2. You have to solve for the third. Keep track of your units. Figure out what the drama is. Like in this one, we fell short. And this was confusing because we had to fix the distance, right? Because she fell short. But we also increased the rate. Oh, yay. And then use that to solve again, and you're gonna need your complex fraction knowledge. So I highly recommend that you check your answer at several midpoints to make sure you're on track, because you don't want to do all this work and then have it wrong, because you won't have any, it'll be hard to go back and track where did I go wrong, all right? So that's my recommendation to you. These are tough, rigorous problems. I'm sorry, but you guys can do this. I have great faith in you. All right, they're also extremely fun when you figure them out, right? Because you feel so smart. Okay, let me go back to this factorial example that I skipped because I was so excited to get to the abstract rate. Use the factorial key on a calculator to help evaluate 11 times 10 times 9 times 8. Okay, now here's the thing. This isn't a true factorial, is it? It would have to do 7 times 6 times 5 times 4 times 3 times 2 in order to be a true factorial. So we can't use the 11 factorial key. It doesn't give us what we want. But if you remember what we were doing here with the crossy out bits, what we can do is say that this is then times 7 factorial, and then we can divide by 7 factorial. I can't show you that on my calculator, but if you all right, no, I can't show you that on my calculator, but now what we see is that if we do 11 factorial divided by 7 factorial, that will cancel out these two and leave you with just that. So on the calculator, enter 11 factorial divided by 7 factorial, and that will give you those 10, which should be, your answer should be 88 times 90, right? Do you guys know this little trick when you're multiplying by a number with a 0? You can kind of tuck it off to the side and then just add it to your answer. 9 times 8 is 72. 72 again. And that's the right answer. See if you can get that to come out on your calculators, because that's a nifty little trick. All right, let me know if you have any trouble with that. Lesson 28's in the books. Great job, you guys. You survived another crazy, wild lesson of advanced mathematics. See you in the video chat.